Thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman.
And I'm Marina Hansen.
And we've been on a little hiatus for the last couple of weeks. There's been some cool stuff going on in the night sky above us. And we're here today to talk about all of it. We're going to try and get into and break down a few of the things that have been going on. And we're going to jump into some news that's current. We're going to also be breaking out to a couple different sections where we're going to talk about some of the cool observations that we've been out making. I'm really excited to talk about that. And then some of the other projects we've been working on too. So we'll get to all of that stuff through the show today. But first, we'll talk about some current events, some news going on for some sky watching stuff, some astronomy news.
Yeah, I'm excited for it. There's been some cool stuff happening during the month of June, and now that we're starting July.
Yeah, I think it'll be great. Through July, we're going to try and pump out some more podcasts for you guys who are still patient enough to listen to us put together a fun night sky podcast. But there's a handful of you guys out there, so I really do appreciate that. And
Thanks,
any more
guys.
comments or questions or suggestions for the show, you're welcome to send those. Drop those in a comment.
Absolutely. If there's anything you're interested in, let us know. We'd be interested too. We'll look into it.
Yeah. You can check us out at nightsky.io if you want some more information. Soon, that will be developing into some of the cool stuff. That'll be really fun. We have some interesting ideas about how we're going to do some stuff, and we've been kind of working on some equipment ideas to expand a little bit of our operation here.
Yeah, we've got some cool stuff coming.
I think it'll be pretty neat. But other cool stuff that's happening right now, we've got a new moon that was back on the 4th of July.
That's right.
Yeah. So we had a new moon then. Now, I think like as of yesterday, it was in the constellation of Leo. And then tonight it's probably real close to Jupiter. I'd figure this evening. I should have checked that. But it's probably up real close to Jupiter and moving on in toward Virgo, I think eventually over the next day or so, if it's not already there at that line tonight. But we should go out and check later. Well, it's cloudy here.
And it's been very overcast
we've had this
the last
spell
couple days
of overcast, which it seems to have been part of the weather pattern for the last 2 years, would you say? Probably
I think
2.
it was within this week or so.
Yeah, it's interesting how that goes, even though we've had a lot of differences between this year and last through the weather pattern over the Northwest. Like last year, it was incredibly dry, a huge drought on the West Coast. And this year, it was sort of an El Nino year. So we had quite a bit more rain, I think, even than a normal year. I'm not totally sure about that. I think California was still having some difficulties from it. As it goes in Oregon, I'm pretty sure what I'd heard is that the water level for a lot of the reservoirs was already replenished early in the year with the amount of rainfall that we had.
Yeah, I can believe that. I noticed it with some of the camping that we've done recently, just out in Eastern Oregon. There was a lot more greenery.
Total evidence of it. Yeah, definitely.
Yeah, it's pretty cool.
Like we had seen, that there's that dry lake bed that we'd been to before, even earlier in May, and it was bone dry. You could just drive out in your car. And this year, which it may have been even a decade, 2 decades since that's had standing water in it, since it's been wet enough in that area to collect water to pool up in that spot, it just filled right back up. It's still a drainage basin for that natural area out there, and it just collected a lot of water after the rainfall, and now there's a lot of vegetation in it and a lot of like wildlife that's been,
a lot of frogs.
Yeah, a lot of frogs, a lot of birds that were pulled into it.
Yeah,
I thought that was really interesting.
Yeah, very interesting. Where do all those frogs come from?
Yeah, where do they come from? If you're out in the middle of the desert, how does a frog get to your pond?
Hundreds of frogs.
Yeah, a ton of frogs. I know they reproduce fast, but gosh, there has to be like one frog that gets there. It's so strange.
Anyway, though, rain again.
Yeah.
This year.
Rain again this year. This weekend's been rained out. So no clear skies for us tonight, but I think by Monday, again, we're back up and running with clear skies in the forecast. So we're going to be doing more observations after that. We can check out where the full moon is or where the crescent quarter moon is on Monday and Tuesday.
That'll be cool. We'll get those observations in.
So last episode, we got into talking about Mars going into retrograde as it was coming into its position of opposition to the Earth. You remember that?
Right.
It was at its brightest magnitude, really bright, stunningly bright. It was really cool being out in Eastern Oregon where we were just talking about, out by that dry and then now wet lake bed. that we were out, able to take some cool night sky photographs of the southern sky, of that section of Scorpio and Mars and Saturn and the galactic center as it kind of moves over into Sagittarius. I think that whole section of the sky is really like one of my favorites.
It's really cool. There's
I've
a
always
lot going on
appreciated
there.
it. Yeah, there's so many first magnitude stars in that area, and just bright objects and interesting things. And there's just kind of tighter collections of stars. And that area is a really interesting part of the sky. Whereas, in contrast to that, in just a couple months, when we're at a point in, I don't know, September, October, there's going to be that section after this, after the galactic center kind of passes by. And then there's this big dearth of first or second magnitude stars for a long time. Once we get into Capricorn and Aquarius, and then past that, when you look into the southern skies, the year kind of moves on. A few things kind of change, and you move away from the plane of the galactic center, or the plane of the Milky Way that we see. And there's less and less stars out past that. So I think it's like Familo is the only bright star, and I think that's still like a second magnitude star.
Oh, wow.
And that's way out there. So this time of year, the southern sky is the coolest, and getting like all these really bright planets in the southern sky, right in that spot, that's really cool during opposition. It's a really cool time to have it, and it's just a really active and easy to observe time. So it's been kind of cool to get to check out.
Yeah, it's been cool. It's been neat seeing Mars move around in that spot.
That's been the coolest thing. So now we're really most of the way through that cycle. If anybody had been listening to the podcast, we'd been talking about Mars going into retrograde. And that was at just after its point of opposition and its brightest magnitude point when we were able to see it, I think right in that last week of May and first week of June. And we saw it now over the last month move really significantly during its course of its travel or its transit in retrograde. So what we saw is we watched Mars move into Scorpio, real close to Saturn, and then drop into retrograde and really quickly move back out past Alniat and Dashuba, the stars that are kind of that head of Scorpio, and then work its way out past that into, I think, like Libra, the small stars that are there, and just sort of further out into that area of space over there. So it really made a really significant amount of distance just in a couple of weeks. I mean, I think you saw it even just with those photographs that we took. We photographed it at opposition, and then just 2 weeks went by, and we looked up again, and we were like, oh wow, look, notice how different it is from this picture we just took. Really, how much transit that really is, how much space is now in between the front edge of Scorpio and the position of Mars. Now you can really see physically each night it really progresses much further in retrograde, back and back and back. So that's a really cool part, to really see the motion and observe it night over night over night.
Yeah, it's really interesting just noticing how much you really can see that it's moving.
Yeah, it's very interesting. And so the benefit is, if you haven't paid a ton of attention to that motion as of this point, the good news is that that's going to continue for the next month and maybe next 2 months. So the difference now is we've just stopped the retrograde motion. It's no longer moving retrograde. It's now reversed, and it will be moving in prograde motion. And this means that it will move in the same method, the same kind of understandable comprehension as the way that the sun or moon moves through the sky, or the rest of the celestial bodies that we look at in their proper motion. So it'll be cool. It'll be cool to check out. But right now, it's interesting as it gets really close to that curve where, how would I describe it? Like Mars is in retrograde motion up and through the last week of June, and then it really moves significantly during that space that it's really transiting. But right as it gets to that point where it's gonna come around and then start moving back in prograde motion, its daily advancement through space seems to slow. So like the last 10 days or so, it's really not moved very much physically in space as it's ended its retrograde motion and then come back around into prograde motion. We don't really see a lot of changes. And it's kind of interesting. I'm not wholly sure why the effect of it times out to be that way. But the interesting thing is now, after maybe let's say the next 7 days, we're going to see a more significant amount of advancement night over night as we see Mars really move a significant amount through that period of time.
Oh, that's interesting how it's slow and then
it is, yeah.
speeds back
That's
up.
sort of the weird thing about retrograde motion and what took so long to kind of understand that it was just us kind of pulling up alongside the planet and then moving away from it.
Right.
And so once we move away from it a significant amount, again, it will slow its prograde motion advancement. It just won't move as quickly through the sky, at least in relationship to the stars behind it, which is sort of our perspective to Mars
Sure.
that changes the stars behind it. It's really weird when you start thinking of it in that way. But yeah, there's definitely some interesting things that Mars is going to do over this next month. So the exciting thing is we get to watch it now. The peculiar thing now, after a month since it was at opposition and at its brightest, it's now half as bright, or I think like a whole magnitude less bright than it was before.
Oh, wow.
Yeah.
That's
So
a lot.
it's probably a plus 1 point something magnitude right now. At its brightest, I think it was like a plus 245. Or is that a negative? First magnitude, like a -1. It's probably, yeah, it's brighter than a first magnitude. It's like first magnitude and then like a negative first magnitude. It's like a number line, you know, like fifth.
Oh, sure.
Fifth is the dimmest, then fourth, then third place, then second
Sure.
place, first place. And then things better than first place get brighter names than that. Yeah. So like the sun is like it's like a 24 or a -24 magnitude. Venus is like a -4. I think Jupiter can hit like a -3 or something.
Wow.
So
That's interesting.
yeah.
It's gone down by a whole magnitude. And
Yeah,
it's dimming because it's moved further away.
it's moved further away from us. Yeah. It's just, well, for one, it's not at opposition to us right now. Which is the best time for us to view it, just because it's going to be straight out from it and probably at its closest position to the Earth. That's if you're thinking two-dimensionally and circularly. There's little elliptical eccentricities to both of our orbits that mean that they get closer and further apart depending on which part of the cycle we're coming into a pass at. So that's why there's some variability, like why they say 2 years from now it'll be closer than it was this year, or whatever they might say about it. So there's a few reasons for that. But when a planet is at opposition to us, that means it's probably closest to us because it's kind of in line, the sun, then our planet, and then the next planet, like Mars or Saturn or Jupiter, whatever it might be. When it's at opposition, it's straight out from the sun, from us. And let's say, like, you know, even if you and I were throwing a ball back and forth or something, if you were there, it'd be closer than if you would kind of spun out another 45 degrees to the side and you were further away, further down at that point. So I think that's why, well, and that's part of why it shows up at its brightest. But it was great. It was great being able to view it at its brightest and then kind of watch it get dimmer over the last period of time.
It was very cool seeing how bright it got.
Yeah, probably. Yeah, definitely just a super apparent object in the sky. It was really cool at the end of May, like how present it was. Just as the sun set, you really just see this big orange orb rise up in the southern or southeastern sky.
It really would catch my eye pretty immediately every time I go outside.
Yeah, I thought it's always really cool. I'm always really excited by that sort of stuff. But over the month, we've been able to see a handful of planets up in the southern sky. That's been really cool, just observing overall. Like we talked about, Jupiter, I think, is still out in Leo, which is going to be setting this month. So I want to try and get as many observations in of Jupiter as we can too. Now there's Saturn, which is doing some cool stuff. We've passed Saturn's opposition on June 3rd. And so that was the period that Saturn would have been at its brightest to us, or in its most optimal observational period, because it's going to be up when the sun will not be up. It was sort of the big thinking of it for a while. To observe something at opposition means that the sun is going to be high noon on the other side of the world. And so it's going to be the darkest part of the sky that planet's going to be in. So it might be a little bit easier to observe when it's at opposition. And the cool thing about Saturn right now, at least at this part of our relationship to the two orbits, do you remember this? How we talked about this before? How Saturn's rings are tilted toward us?
Right. Yeah,
So,
I remember that.
Yeah, and that'd be really cool. And we only had a little bit of a chance. Remember when we were looking in the telescope at Saturn to really observe that, just because the resolution that we have, it isn't strong enough. Or it's
Definitely
not good
not
enough at all. Yeah.
It was cool though, being able, you can see it though, even with a terrible kids telescope from the 90s. You can still see Saturn's rings pretty
No,
well.
it's cool. Yeah. And those are the discoveries that people hundreds of years ago were making too, and the resolution they were able to have. And so it's so fun that, we get to have the fun of that experience of getting to kind of feel it and observe it the truth of it, the way that it does exist. Those moons out around Jupiter do exist. They do revolve. It's really cool. And so we get to make those discoveries ourselves, but we also get to back that with all this really cool science now that we have. And I think that's a really exciting part of it. And there's some cool science news to get into also. But with Saturn, as we just talked about Mars has been in retrograde. It's now stopped retrograde and it's swinging back around and heading back eastwardly towards Scorpio. Saturn has also been in retrograde, but Saturn's retrograde motion is really quite a bit different and not as observable or as powerful or as interesting as the Mars retrograde motion. And so I don't know if you've been able to see it. I really haven't been, but Saturn is doing really what it ends up being essentially a really small little backtrack, just a few degrees remaining in the same constellation of Scorpio. And it's just kind of rolling a few degrees up and then back in prograde motion. But it's doing that over a much longer period of time. And that's probably why we haven't seen that significant amount of motion, it moving and tracking backwards along the ecliptic for, a whole constellation's worth of space. We haven't seen that, but what we are seeing is between the periods of March 14th of this year and then August 2nd. So we're coming up to the end of the retrograde motion. Saturn, is in retrograde in Scorpio in the southern sky. And then after that, on August 3rd, it starts its prograde motion again. And I think we're going to kind of watch it over the year, probably, into the fall as Scorpio and Sagittarius start to set. We're going to probably see Saturn set, but we're going to see Saturn work its way back to the end of Scorpio and then back into Sagittarius. And we'll see it there for, I guess, probably like next year. We'll observe when Sagittarius comes back up in the summertime, we're going to be able to see Saturn sitting back another constellation. And that'll be fun too when we get a year into it and we see like, oh, wow, look at how everything moved around in the last year.
That'll be really interesting to see.
Yeah, what things are kind of in the same spot, what things are in drastically different spots. That'll be pretty cool. But we were talking about a lot of the science stuff that makes it really interesting now, how we get to make these discoveries with the telescope that we have that's real similar in design and essentially in resolution as what people a few hundred years ago had, like Galileo and Simon Marius when they were first making their observations of Jupiter. We get to do those same kind of really fun experiments. We get to see those things and, kind of make some deep sky analysis or, investigation. We get to kind of run those experiments ourselves. And I really like getting to do that. But we also get to back that up now, being in 2016. We get to back it up with incredible scientific data and results and imagery that are from all these really cool probes that we sent out into space now during the last century that have been able to collect real photographs or real images of all these planets. I think it was just last year we finally had photographs of Pluto for the first time.
Yeah,
I thought that was fun. Yeah, I remember in high school they didn't have photographs of Pluto. We just had a little white sphere in the textbook.
That's pretty fun.
And it said, yeah, to be announced. They gave us their best picture, which was like a fuzzy blown out dot surrounded by blackness. It wasn't it was nothing. So it was really cool. We have really high definition images of Pluto, of Saturn, of Uranus and Neptune. Really cool stuff of Mars and Venus and Mercury. And we just had news that all this cool stuff is going to be happening with Jupiter, right? And so it's really cool. Yeah, what was it?
Juno.
The Juno probe has just arrived at Jupiter, which is really cool to think about. When you look at Jupiter tonight and you're like, whoa, we a few years ago shot something there.
Yeah.
And did you hear about how big it is?
You were telling me something around like a basketball court size.
That's what they say. Yeah, it's almost a basketball court. I think it was like a long cylinder, and and then there was two wings that kind of like folded out. I think those are solar panels, you know, they folded out. And so that's probably where the radius is something like, you know, or like the essential part of the equipment is probably much less than that. But I think the spread, the wingspan of those solar panels is probably near a basketball court, it says.
Wow, that's huge.
It's really big. Okay, so in contrast to that, that's 2016. That's what we have there now. And it's really interesting. There's a lot of advancements that we've made. And to kind of compare it, I was thinking about as Juno arrived, I think it sent this tweet out, and it was its approach to Jupiter. And what you could see were the 4 Galilean moons kind of doing their orbit around Jupiter. So we could kind of observe the motion of the moons as Juno was approaching, you know, the days in advance of Juno getting to Jupiter. And the cool thing is that back in the 70s, the Voyager spacecraft did basically the same thing. And so we had these old, I think it was Voyager, maybe it was the later one. We sent a few to Jupiter by this point. But I remember like, yeah, the first images of Jupiter coming from Voyager and seeing like what they had back in 1979 when they sent those 2 spacecraft out. And those really did, I think, they might have done an orbit. I'm sure they had some tricky ways of getting into orbit and then slingshotting out of orbit to kind of continue on. Amazing how Jet Propulsion Laboratory could figure that sort of stuff out. Well beyond me. But it's really cool. I think for Voyager 1 and 2, I wrote down it was March 5th, 1979, which seems ancient, right?
Yeah. 79.
think of the truck that you would have bought at a new car lot in 1979, and that being the same technology that built a spaceship that went to Jupiter. It just seems so different now, right? You're like, well, yeah. I mean, it'd be way easier to get a spaceship to Jupiter with a 2016 truck. But yeah, so March 5th, 1979, that was the Voyager 1 as it passed Jupiter. And I think it had something real similar to what we were talking about, those images of the moons revolving around Jupiter. And then it was Voyager 2 on July 9th, 1979. And those were when, we got these really cool, some of the first digital images that were transmitted back to Earth that were actually physically of that planet from that planet. And that was a really cool experience, especially for Jupiter, since it was such a fascination for a long time, since like Galileo and all the astronomers at that point since had been looking at Jupiter through some resolution. We got to see the bands, we got to see the storm, but it's not there, it's not closer, it's not more than that. You can get a really good view of Jupiter through a nice telescope. And now with modern technology or say, I don't know, turn of the century technology 100 years ago, there's probably really cool views of Jupiter that you could optically see. But now, since we have all this imaging equipment, all these screens and all these ways to kind of blow it up, you can see it in a way that people really could never have done before. And so the cool thing is with Juno, we get so many technological advancements. It's just a much more advanced mission, and it's more specific to Jupiter itself, like a few other trips in that area had been. But there's a lot of scientific research that they're going to be able to do now because this Juno probe is there. And I think, and you were probably checking this out too, it's there to observe auroras. Did you hear about that?
Right. Yeah. I read just a little bit about it.
It's interesting. And so the part of that's a little different. It's essentially just a lot of, there's some soft selling that's going on in the media around Juno from NASA. Mm-hmm. Like we're sending Juno there to unlock the mysteries of our solar system, and that's a way to do it. The scientists did not write that when they pitched the idea. They have very specific outcomes that they're trying to get, and exact goals or exact experiments that they're trying to prove or disprove that may and then interpret the meaning or the connection of our planets in the solar system at its dawn. But there's some other cool stuff. That's like the more practical pieces that we could talk about, and that would be like the aurora photography, or I don't know if it's photography, but aurora imaging that they're trying to accomplish. So there's a handful of different sensors that are on there. There's it's a documentary online. If you look up Juno probe documentary, I'm sure you pull it up. It's like an hour. I think NASA produced it, and it really goes through specifically with all the key players involved about the different imaging modules that are built into Juno. And that's sort of what it is. It's all these different teams that have these experiments to run with their imaging equipment. And then that's built into Juno. So there's a team that wants to do aurora photography. So they have, or, you know, storm photography or something like that. So they have this infrared and visible light camera that they're going to be taking these really detailed and close up and far away images of Jupiter to kind of do stuff that we hadn't really been able to do before with, perhaps. There's these other things that are like these radiation collectors, like as the craft rotates, as the probe rotates around, it kind of picks up this 360-degree field of radiation. It's supposed to be calibrated to be understood, and you're going to get some kind of radiation level of whatever's going on around Jupiter. But there's a whole bunch of different systems that are there, and
yeah, it seemed like a
cool?
lot.
Yeah, there's a bunch of different pieces.
Did you see when they started Juno?
Oh, you know, I'm not sure. I should look that up.
Yeah, I was thinking that's part of the information I don't know.
Juno was launched August 5th, 2011, according to NASA. I guess they did it. They might know. August 5th, 2011 to July 6th or 3rd or something, 2016. That's a long trip to Jupiter. But yeah, that's what it takes. It's so interesting. It's really interesting how it does that. But yeah, they're going to do aurora photography. I think they're trying to understand a few of the pieces of why like charged particles do that as a phenomena in the upper atmosphere of planets. So it's interesting. I mean, they might be able to do some of that here too, but it's cool. I think Jupiter is one of the other areas that has these really strong aurora fields that they're going to be able to take images of. The new thing about Juno is that all of these other craft, these probes that we'd sent to Jupiter, they weren't really able to move past their equatorial orbit. So the orbit that would be essentially around the equator of the planet. And that's why we get these kind of face-on images sort of running North Pole to South Pole. And now what we're going to be able to do with greater flexibility with Juno is make images from the Arctic or Arctic Circle area, like up at the 49th, 48th parallel of Jupiter. So we can be up higher and kind of look down at like where Alaska would be, you know, if we were kind of matching stuff on Earth. So we can kind of move the probe up to be doing more photographs of the polar regions, which is going to be cool and specific to this aurora photography or these aurora imaging projects that they're talking about. And these storm imaging projects, they're going to be looking into like how these different gas storms really work, or, you know, if they're changing, or they're just going to be able to do these more intricate observations of them. And I think what I was hearing is that they were trying to pull a lot of information from amateur astronomers too. Apparently there's a lot of it's maybe marketing, but what they're going to be doing, as I understand it, is making these observations of these specific storms. So we know about like the big red spot on Jupiter.
Right.
That's one of the storms. There's a number of other storms that are observable with amateur equipment, and depending on the time of year or the time of the observation. But there's people that do track this stuff, and serious astronomers and scientists that track this stuff that don't have a probe at Jupiter. And so they're trying to take this data about what these storms are like, or which ones are interesting or have interesting features. And I think they're trying to get these, they're trying to collect data on those storms or those systems and demonstrate or see how they're modeled, see how they work, if they're working kind of the same as they do here on Earth for us, or if they move quickly, you know, that sort of stuff. So
that'll be really interesting. Yeah, to see the results from some of those studies they're doing.
Yeah, I think, what's that called? The Coriolis effect. Have you heard of that before?
I feel like maybe I recognize the name, but you should tell me.
The Coriolis effect is I don't know. It's gonna sound really verbose as I say it. The Coriolis effect is the effect caused by the rotation of the Earth, the spinning of it during the day, okay. And what that causes basically is weather or banding. So you know how like when we were in Hawaii for our cool vacation, when we got to see Canopus, if you guys want to go back and check out episode 9, Viewing Canopus of the Night Sky podcast. When we were back in Hawaii, we were looking at Canopus out in the southern sky. We were further south. And so in that area, we had exceptionally good weather. But they talked about like the trade winds that would come through.
Right.
And so those bands, they run, let's say, westward But then on the other side of the equator, they would run eastward. And so this opposite rotation of a banding that doesn't happen at the equator. Does that make sense? So you get these weather patterns that kind of build out over a spherical shape as it spins around. It's sort of like if you were to imagine, I don't even know if they have something like this, but like if we had a sphere here on the table and or like a ball, you know, and we wanted to spin it like a top or like a basketball that you want to spin around. And let's say there was like a layer in it that was sort of a fluid, kind of a mixed fluid that was different colors or that was separated. As you'd spin it, you would see those kind of by centrifugal force, they kind of pull and they sort of spin around.
Sure.
They sort of like, you know, not mix in, but they'd almost really through the Coriolis effect, at least in zero gravity, they'd sort of separate out from each other. So there'd be different materials at the top, different materials in the center, and different or in the mid ranges, and the different material at the equatorial range at the mid level of it, just depending on its density and on the rotation and on a lot of other stuff. But that is what we see when we look out to Jupiter and we see these bands, which is really cool. So that's why we see the different sectional divisions of material or, you know, of color on Jupiter when we look at it.
That's really interesting.
And yeah, it's caused by this Coriolis effect that makes weather banding.
Why do we see it on Jupiter and not other planets as much?
That's a good question. I believe, well, most other planets don't have atmospheres in the ways that ours does. So I guess we do observe it on Venus, but you can't observe it because it's all the same color. Does that make sense? Or it's like it just seems brown or like a tan green. And Mercury doesn't have an atmosphere. Mars doesn't really have an atmosphere that would demonstrate it. Jupiter is a great example of it. We do see banding in Saturn, but from a telescope perspective, it really does also look tan. And the best observable pieces there are like the rings and the moons that you can see around Saturn. I think like Neptune, you see the banding a little bit, but it's like the light blue and the dark blue.
Sure.
But, it's hard to see. The best example would be Jupiter or be Earth, you know, here for us to kind of see like those weather pattern systems that move east to west. But it's kind of cool. Yeah, it's going to be exciting for the Juno team to get into it and start doing a bunch of science for a long time. You know, I love this sort of stuff. I remember like when Cassini reached Saturn. Do you remember that? That was back in 2006, 2005. And sometime around then, that's when I think Cassini, there was another name too that I'm forgetting. But yeah, that's when the Cassini probe reached Saturn, and that's when we got that probe that left Cassini and made a successful drop onto Titan, and it was able to take these photographs as it passed Titan's atmosphere. Another one that just has a really dense methane atmosphere that's just brown or tan that you couldn't see through. But as you get below that, what they were able to photograph was all these ridges and methane based grooves in the land, like you would see tributaries into a river system and then into an ocean. It was really interesting. You see like mountains and erosion occurring in this sort of convection cycle as it would, you know, pull up methane and then rain it down and then have it draw in canyons and then pull back up into an ocean and do that again. But a very alien world. But yeah, it was really cool to get to see those images, just these kind of eerie topographic landscapes.
Oh, that is cool. I think I vaguely remember that back in 2006.
Man, that's so long. That's like 10 years ago now. We've done a few space missions now, all robotic stuff. And like I wonder what's going to be. I wonder what other stuff they got going on. I know they're launching, you know, more stuff all the time. Some of it I'm more interested in. I'm most interested in when it's showing up. I think the next thing showing up is like this European project that they put together. I remember they put together a probe that was going to Mars, and it ended up choking on landing. It got to Mars, that went out, and then like something shook, and it deployed landing gear in the wrong time, and it broke. Bummer. Huge bummer.
But there's something new coming up.
Yeah, some other European project. I'm not sure which planet it was. I think it was Mars or it could be Jupiter too. I'm not sure. But yeah, pretty cool little stuff about Juno finally showing up.
Yeah, it's really cool. I'm excited to see some more photos from that.
Yeah, I want to see some more photos from it. But the other part of it is I really want to do more photos from Earth here of star stuff as part of our projects that we want to do for night sky.
Yeah.
And we've been trying to do that a bit, which I think has been cool, but trying to get into more astrophotography stuff where we've been, trying to go out with, so we have like some better digital SLR camera equipment. And I bet a lot of you guys out there have, some good DSLR equipment too that's ended up, showing up in the last few years. Any of these cameras now, crop sensor or a cheaper camera, anything that's really more modern, it has these tremendous sensors that you can pump the ISO, the gain up on to these really high levels. And once you get up to like that's 3200, 6400, whatever is past, there's a few other options past that on both the Canon and the Nikon side, and whatever other camera system you use, you can push the ISO up really high, like we've been doing.
Yeah.
And that gives you so much more sensitivity to light. And that's where you get, and I'm probably not breaking news to anybody that's been on Instagram or, on anywhere on the internet before, but you get all these really cool low light photographs that have these really sharp, crisp stars in them. It's not the star trail photos, those long exposure images where they track and streak across the sky as they rotate. It's not really that look. It's just a short, long exposure. But there's these cool options where it's really wide, right?
Yeah.
So you get to capture more light with like an open aperture and a high ISO. And then this really wide angle is what allows you to keep those stars looking really tack sharp, really crisp in the photograph. That's the real secret to it, is the wide angle lens. And so what did you find the best? What do you think is the best like lens stuff, for astrophotography?
I'd heard the 14 millimeter is pretty good. I think there's, what is it? Is it a Rokinon one?
Yeah, that's a real cheap one that we
for
we
cheap options, for affordable options.
I think that's
$350
really cool.
is cheap.
Yeah,
for lenses.
Oh yeah, it's super. But the best thing is that the wide angle, like you're talking about, a 14 millimeter at 2.8. And so if and not everyone out there might be a photography buff or something, but I think the lower the number for the minimum f-stop, the wider the aperture and the more light you can collect to get brighter star photographs if you're trying to photograph these stars. So that's why you want that, but you can get away with a lot now. Just a regular, like even if you have an 18 to 55 millimeter kit lens, that's like a variable 3.5 to 4.5 or something. That's still going to be an f3.5 at 18 millimeters. That's going to be really a really wide angle view, and I think you're going to be able to do a lot with that as star photography goes. I think they say, I think it's like not more than 35 millimeters. Is sort of a rule of thumb. Like if it's a 50 millimeter lens, you're really not gonna. You're going to get star trail. You're going to get these tracks to start building up if you have it open for 20 seconds.
Yeah. I have noticed that. I remember on a camping trip we did, I think it was a couple of years ago now, I was using that 50 millimeter that we had, and also the 35, and just doing some kind of nothing for fun photos, just to mess around with the camera a little bit. It was after I got my D7000.
Right. Yeah.
So I was seeing what I could do with night stuff with that. But I noticed with those, there's a little bit of blur no matter what. You really can't get away without the blur. But we have that 28 millimeter that we've been using. And what is that? It's 28. What's the F?
Oh yeah, that's an f2.8.
2.8.
Yeah, which I try and set it to.
Yeah, and that works really nicely.
Yeah,
we've done a few shoots with it now with your new camera.
Yeah,
with your D3.
It's been cool to put together.
Yeah, you've got. I think even just this last weekend we were in Southern Oregon, and
that was cool. Yeah, I had a really nice time taking those photos with you. Yeah, we went down to Southern Oregon for over the 4th of July weekend. And took some photos of the southern sky.
Yeah, it's really cool. It's fun taking the photos. It's hard though because you pick up more stars. I was gonna say it's cool because you get to look at you get to see Mars in your photo, you get to look at Scorpio or whatever constellations are in your photo.
Yeah.
But it's actually also really hard too, because you pick up so many more of the stars and so much more of the light from it that it actually ends up becoming more difficult to see sometimes or pick out
Yeah,
which
I
your
feel
stars
that
are
way
because you
too.
have so much of them.
And that's an interesting thing is, yeah, you get some aspects to the photography that are different than the way you get to see the sky. I think if anybody wants to try something like this, they should go look, if you're in the northern hemisphere, that is, look to the galactic center. Yeah, look out toward the galactic center. It's probably a pretty rewarding spot to get some photographs from. That's where we were taking some photos,
Right.
looking out to the south, and that's into what we were all talking about today. That's in looking out toward Scorpio and Sagittarius, and then that band of the Milky Way that cuts up toward Altair, and then up into the summer constellations overhead. But that view out to that section, that's the Milky Way galaxy, which is really cool, and it definitely shows up in a pretty impressive way when you leave the shutter open for a few seconds. What I recommend is probably about 20 seconds. There's a good rule of thumb and a little system to get good star photos, but to keep it kind of light, at least for the moment, I'd say about 20 seconds or so at around uh, 30 millimeters. I wouldn't do any longer of an exposure than that if you want to try and stay away from the star trails. But I try and say, like, I'd expect most people out there probably have an 18 to 55. If you drop it down to 18 millimeters and have a 20-second exposure at your highest ISO, you're probably going to come out with a couple pretty cool astrophotography pieces that you can edit on.
Yeah.
And they do need a little bit of editing. In fact, one tip I might add to that is watch your white balance. It's going to be set for daytime light. It's going to come out a little purpley or a little orangey. And what you're going to want to do is drop that into some software if you can. Photoshop Elements would do fine, or Lightroom if you can do it. But whatever kind of thing you can do to process your image. And you're going to want to pull back in a ton of blues and maybe some purples, but really like a ton of that blue light you're going to want to pull back in. I think it's like the tint side of it, or the color temperature side. You're really going to want to push that toward the blue and that's where you're going to get back a lot of that natural look in the darkness of the night sky and the color of the stars and stuff. So there's some cool ideas, I guess, you can kind of poke around with. Oh, did you want to talk about the ratio? I think
Oh,
that's probably worth
yeah.
discussing. Yeah, there's a little ratio. I don't want it to get too technical if you're not like a big photography person, but maybe you want to do some stuff looking out, in the evening sky tonight or over the next week, and you want to try some photographs. There's this helpful kind of uh, I don't know if it's a saying, this helpful kind of equation to set up your shot with, to set up these photographs with. And so what I understand is it's the 500 rule. Let me read it here for you. Uh, Take 500 and divide it by your focal length to determine the maximum number of seconds of your exposure before star trails are apparent. So in this example, a 24 millimeter lens on a full frame camera, we would take 500 and divide it by 24. So 500 divided by 24 equals 20.8. And that would be an equivalent to a 20-second exposure for us. Any more than a 20-second exposure, we're going to start seeing that drag. And I think what this is based on is the rotation of the Earth. As the Earth's day progresses and we see these stars rise up over the eastern horizon, they're poling, they're kind of moving up, and you wouldn't notice it maybe, but if you're out to see the sun or the moon rise, you notice how fast it goes by. It's within 3 minutes that much of the sky moves past the horizon. So even every 30 seconds, a significant amount of movement happens in the sky, and that's what causes these drags in the star field above us. Otherwise, we could just leave our exposures open for a really long time, and we just get these super dark, deep, crisp images, which is similar to this other process. Have you heard of that before? This is back what they used to do a lot of the time. And what they still do in more of the serious locations of doing astrophotography is they do stacking.
Oh, I
Heard of that
remember
process?
stacking. Yeah.
Yeah,
Where you use layers.
they use layers to duplicate the light that was in the file previous to it. And so they add that and then add that and add that. And that's, I think, the same method that they use for a lot of these deep sky photographs that we get to see from Hubble or from other telescopes like that is they do a system, just a whole set of images that they layer on top of each other to boost the brightness of it, to boost that clarity and resolution of. It's a really interesting process, though. I don't understand or really claim to understand all the ins and outs of it, but it's cool learning about astrophotography and deep sky imaging.
It's really cool. It's a lot of fun to do. And yeah, we'd both definitely recommend it. If you have a camera, it's really not that hard to
Yeah, it's probably not that hard to do. I think it's probably definitely worth setting up. But yeah, I think it's pretty neat stuff. I'm glad we got to do more astrophotography. I want to try and get that going with you too over the next couple of weeks. We got to do more stuff, especially while it's in summertime. But I don't know. I think it'll be good. Yeah. I guess that probably is most of our stuff for the explanation of the astrophotography stuff that we're doing. Send us some questions or send us some pictures if you guys ever take any cool pictures.
Oh yeah, we'd love to see.
Yeah, there's probably like 100 people that get to check this out.
Maybe.
Yeah. No, that's other than me or spam or something like that. But yeah, if anybody gets to check any cool deep sky stuff out or any cool wide angle astrophotography out, let us know. Drop us a comment or a review or whatever that is. You can check us out on iTunes. Try and subscribe to our podcast if you've enjoyed it. We'll have a few more of these coming soon. I think we have a couple other cool ideas to sort of spread some of our night sky stuff around. As long as we're kind of we're trying to get it together. We're gonna get more night sky stuff going.
Yeah.
I'm really excited for a few of the things we've been working on.
I'm really looking forward to it too. Keep track of us at nightsky.io.
Yeah, nightsky.io. We're gonna get that up and running. And we're going to get way more content or just way more pieces up there for everybody to check out and to get into, to learn about some of the sky stuff that they can check out in the sky above them tonight and for the rest of the summer. I think that's what we're going to try and do next week or Monday or Tuesday because it's cloudy right now.
Yeah.
We're just going to hang out, watch it rain for a little while. That's what we get here in Oregon. So on behalf of Marina Hansen, my name is Billy Newman, and thank you very much for listening to this episode of the Night Sky Podcast.